Welcome to the bullet problem. Imagine you have a gun with you, which you use to fire a bullet perfectly horizontally straight into the air. Provided that the bullet does not hit anything in its path, it's eventually going to come down and hit the ground. I hope there's no doubt there, right? Due to the gravity, it's eventually going to come down and hit the ground. There's another bullet with you which you drop exactly at the same time when you fired this bullet. This dropped bullet is going to come down due to gravity and hit the ground. The question to you is, which of these bullets hits the ground first? The answer is quite simple. It's simple physics. Let's see what are the forces acting on each of these bullets, right? If I talk about the vertical forces acting on the right bullet, which you have fired, it will have some force or some velocity taking it in this horizontal direction, right? Let's assume it has some horizontal velocity v, not exactly a force, but yeah, some velocity taking it forward. There's going to be a counter force due to air, some drag acting against this as well. Now if you look in the vertical direction, there is one force acting on it, pulling it vertically down. This is the gravity, right? There's no other force pulling it down or pushing it up. Provided you have ignored all the nitty gritties, other effects like the Coriolis effect, ignoring the curvature of the earth, etc., etc., there is one force acting on it vertically down, which is the gravity. On the other bullet, is there any horizontal force? There is none. It's zero. There is, however, only one force pulling it down, which is again the gravity. Basis this simple theoretical understanding, you can derive and say that both the bullets are going to hit the ground at the same time. Pretty counterintuitive, but wait and see and look at this actual physics explanation. I have a height at which both the bullets. Welcome to the bullet problem. Imagine you have a bullet, you load it into a gun, and you fire it perfectly horizontally straight into the air. Now, provided the bullet does not hit anything in its path, it's going to come down eventually and hit the ground, right? You have another bullet which you drop at the exact same time from the exact same height where you fired this particular bullet. You drop this bullet perfectly vertically down, it comes down and hit the ground. Notice and remember the same height and dropping it perfectly vertically down. The question to you is, which of these two bullets, the one fired horizontally or the one dropped perfectly vertically, which one hits the ground first? Pause the video, try to have an answer to this question. Now, let's understand the simple physics behind it. If I look at the bullet which was fired perfectly horizontally, it has some velocity taking it forward, right? Let's assume it's v. It has some force acting against the velocity as well. It could be some air drag and other forces, right? Something pushing it back. But what interests us the most is the forces acting in the vertical direction. Which are those forces? It is only and only the gravity, right? Now, if I look at the other bullet, which is being dropped perfectly vertically down, what are the Horizontal forces? There is none. It has been dropped perfectly vertically down, right? What are the forces acting in the vertical direction? It is just the gravity, correct? Now, since they have been dropped from the same height, as I mentioned, the gravity is going to act exactly the same on both the bullets, and both the bullet hit the ground at the same time. It seems pretty counterintuitive, but let me give you a physics explanation to this. Assuming they were dropped from an height h, I have a simple physics formula for such situation, which is h equals to ut plus half gt square, where u is the initial velocity, right? G is the gravitational pull, and T is the time it takes for the bullet to hit the ground when dropped from the height edge. What is the initial velocity for both of these bullets? Obviously, for the bullet on the left hand side dropped perfectly vertically down, it was dropped from rest, right? It was at rest when it was dropped, so its initial velocity is zero. Initial vertical velocity, that is what I'm talking about. For the other bullet, people might assume that it had a velocity v, but mind you, that is a horizontal velocity. What was its initial velocity in the vertical direction? There was none. There was no velocity that it had in the vertical direction. So, the velocities, initial velocities for both the bullets in the vertical direction is zero. So what does this formula then turn into? If u is 0, h becomes half g t square. Solving for t, because we want the time it takes to hit the ground, right? 2 goes to that side, 2h equals to gt square. What does t become? T square becomes 2h. The g goes to the other side by g. Now t would eventually become t equals under root 2h by g. This is the final formula. H is the height from which they were fired or dropped, which is the same for both. G is the gravity, which is same for both. So the time taken for them to hit the ground is same for both the bullets. Pretty counterintuitive, but pretty interesting. Thanks for watching.